Take a look at practice question set number 8 here. I have a quiz on this tomorrow, of course. Positively charged object is brought near to but does not touch one end of a neutral metal rod on an insulated stand. The opposite end of the metal rod is grounded. The ground is removed. The positively charged object is removed. As a result of this procedure described above, the metal rod will become what? Listen, when you see a question like this, please, for heaven's sake, please do not try to just remember an answer. Don't try to just work through this in your head. Okay, for the most part, we're going to be more successful if we draw a picture of this. We see what's happening. Okay, so let's draw that picture. Too many of us try to oversimplify things. You know, we see this big problem and we look for one equation that works, that will just magically solve the whole thing. Or we see this big problem where multiple things are happening and we just look for one tidbit from our notes that will answer the question. Okay? We've got to think about what's going on here, okay, rather than try to memorize something or oversimplify it. Positively charged object is brought near to but does not touch a neutral metal rod on an insulated stand. Here's my neutral metal rod. Right there. I bring a positively charged object nearby. It doesn't matter what the shapes are. It's kind of reversed this time versus what we did with our examples, right? But whatever. On an insulated metal stand, I don't need to draw an insulated metal stand. It's just, I've got to draw it in the air. It's insulated. It's not touching the ground, right? But then, then I ground it. It says the opposite end is grounded. Just so you know, if you didn't remember this, it doesn't matter which end is grounded. Same end, opposite end, top, bottom, whatever. If you don't like the ground wire drawn there, draw it somewhere else. Okay, whatever works for you. It's grounded. What happens now that it's grounded? Well, nothing happens to these positives, but these negatives are going to be pulled toward the positively charged object. But you're also going to get negatives coming up from the ground into this this neutral object. Now this thing that was neutral isn't neutral. Now it's negative. Not permanent though. It isn't permanent until I remove the ground wire. It says the positively charged, or the ground is removed, then the positively charged object is removed. What do I got? A negatively charged object. So the answer is D. Now, one thing that we could have added to this question that we didn't, it could have said, it's negatively charged by induction. It's negatively charged by conduction. What would the answer be then? By induction or conduction? It would be induction. Even though conduction is clearly taking place between the Earth and this object, the thing that did the charging, this positively charged object that was doing the charging, that is not touching and it's not transferring. And that's what's important. The thing that's causing it all isn't touching, isn't transferring, it's induction. So D's our answer for that. Now this one's a bit tricky. Two identically charged electroscopes are shown below. Electroscope 1 and electroscope 2. The leaves are spread apart on both of them, which means that the leaves have got to be charged, right? What's the charge on them? Positive, negative? Don't know. Just know that they're charged. Student touches electroscope 1 with a neutral metal rod. Student touches electroscope 2 with a neutral glass rod. What's the difference there? Yeah. One's a conductor, one's an insulator. Good. When we touch this thing that's charged with an insulator, what's going to happen? Nothing. You might get some electrons go, but what they mean by that clearly is that you're not going to get any dramatic transfer of electrons there with that insulator. So you're going to find electroscope 2 just remains the same. So the answer is going to either going to be B or D as a result of that. So now what happens to electroscope 1? Do the leaves come together or do they stay spread apart? If I touch electroscope 1 with a conductor, then we're going to transfer some charge, right? If it was negative, it's going to become less negative or neutral. If it was positive, it's going to become less positive or neutral. We may not find necessarily that the leaves completely come together if the electroscope doesn't lose all its charge, but we're going to find that they come somewhat together at least, right? The answer that they mean to be correct is this one. Because as the leaves lose charge, they become less like charged or neutral, and they come together because of, not because they're attracted, but because of gravity. It just pulls them down. Reality is, they may not completely come together like that. They may stay spread apart some, but certainly not as much as they were. And the next one, neutral ball, positively charged ball, neutral styrofoam ball covered with tinfoil. Why do we put tinfoil on that? To make the styrofoam conductor, yeah. Charged metal sphere, so we get two conductors here, right? Neutral conductor, positive conductor. What are they going to do? 100%, what are they going to do? Attract each other, right? They're going to attract each other. And then eventually they're going to touch each other, right? And then they touch each other because they're both conductors. What's going to happen? They are going to repel, but why? They're going to try to equalize, balance out the charges. They may not balance because one's a lot bigger, right? But they're both going to become positive. And positive are going to repel each other. Right? If it was 0 and plus 10, it's more likely going to end up being plus 2 and plus 8 rather than 5 and 5 because they're different size. But they're still positive, and they'll still repel each other as a result of that. In the end, all you had to do really in this question is recognize that they attract, right? Positive attracts neutral because it's the only option that we would have then. Remember this question because we're going to come back to this when we do question number 5. Electrostatic spray nozzle. This is like the painting almost, isn't it? You spray this pesticide through this charged needle. What happens to this pesticide as it touches this charged needle? It becomes positive by? Yeah. Conduction. Positive by conduction. Positive by conduction. Okay, so these droplets are positively charged here. Oh, look at that. The droplets leave the nozzle with a positive charge. By conduction, but what is it? The movement of the electrons or protons that make a conduction? The movement of the electrons, of course, right? It's always going to be electrons. B is our answer. And 5, I really like finishing off with this question. It's a great one to finish off with here. It's going to refer back to 2 or 3, whatever that was. The charged droplets are kept from being blown off the leaves by the wind because the charged droplets do what? Like, picture this. Here's the leaf that is presumably neutral, and then you've got these droplets that are positive. Why are the charged droplets prevented from blowing off of the leaves? What does positive do to neutral leaves? It attracts. It creates a separation of charge. Here we go again there, Kelvin, right? Creates a separation of charge in the leaves. Before you were asking, I was saying, like, yeah, technologically, I'm not sure. There we go. There's a perfect technological example, right? Positive creates a separation of charge in the leaves, which means they're going to attract, right? Make sense? So the answer would be C. But hold on for a sec. That's correct. But hold on for a sec because I want to draw your attention to something else. Here we have positive and neutral attracting. They touch, they stick, right? Here we had somewhere we had here we had positive and neutral attract, they touch, and then they repel. Why? Why do these guys repel after they touch? Why do these guys not repel after they touch? Bryce?
Because once
No. No, that's a good guess, actually, but that's not it. Jennifer? Right. The difference is the plant and presumably the pesticide are not conductors, right? So they attract each other. Certainly they attract each other. Positive attracts neutral, but when they touch each other, you don't get a dramatic transfer of charge taking place between the two. But when those two metal balls attracted each other and touched each other, because they're both conductors, you get much more easier transfer of charge taking place there, which means they might not balance out, but they try to balance out, become like charges and repel. Okay, does that make sense? Eventually that might happen here too, but not in the immediate future, at least. Daniel?
two insulators more likely to conduct the charge.